Hi, in this episode I'm going to do something slightly different and I'm going to introduce a fellow Raspberry Pi Pico engineer, Jordan Broome, and I'm going to let him tell you a little bit about his journey and his projects with the Raspberry Pi Pico. Jordan Broome comes at this from a different direction to me. I'm at heart a software engineer and solution architect. Jordan is a hardware engineer. So it's interesting seeing our differences as how we come to the world of projects. Please don't forget to like the video and to subscribe. I really do appreciate it. So today I've got Jordan with me, Jordan Broome. Welcome, Jordan. Thank you for joining me on my channel and into this one exciting world of Picos and Pico development. So would you like to give us just a brief introduction to yourself and the places you come from?
Yeah, I graduated from Texas Tech in 2015 with an electrical engineering and a math degree. And I went and worked for Lockheed Martin in as a radar systems engineer. And we were responsible we took our equipment, we got deployed to Nevada, and we harvested tank radar data. And the whole goal was to determine the highest electronic warfare threats. It's a really cool job. I had actually interned at SitePro the summer before that. The oil field was booming, so I had some buddies that reached back out, and so moved back to be closer to home and be a part of a startup company. And since I've been there, I've been doing automation in the oil and gas industry, municipal water, and ag. So I've been involved in Windows-based applications for automation. We have a cloud system that the customers actually log into and they can interact with, and they can use that to remote control and monitor their sites. And so since I've been at SitePro, I've got to do CAD modeling, PCB design, embedded software, some higher level stuff with C# on the WPF side, tinkered around in Azure with some different things, but really my job is really meshing hardware and software together. So we have a really good team of software people. The operations side has a lot of ideas. They can go pull wire and bend conduit all day long, add instrumentation, but it's kind of like taking those two things and making sure they mesh and there's no problems.
It sounds fun. Playing with microcontrollers, playing with firmware and hardware is a fun place to be, I think.
Yes, it's been awesome.
So we've been talking now for about a year, I think.
Yeah.
Remind me, because you originally reached out to me. Where did you find me from, and what started that journey and that conversation?
Yeah, I was mentored by an engineer. He was an electrical engineer as well, and he took me under his wing, and we developed a credit card size microcontroller based a cellular microcontroller based board that could pull RS-485 Modbus data and send that back up to our cloud services so we could funnel that back into the other sites. And so that guy, he was the team lead, no doubt, and he taught me a lot of good stuff. I got exposed to the real-time operating system, the task switching, heap and stack, really basic stuff for a double E that's not very well versed in that type of stuff. And then after he was no longer with the company, I still just had this itch to continue with that knowledge that he had given me. And I saw real value in doing it, but I also was also hesitant because it's also it's a big feat for me, and especially when you don't have a lot of support to help you or you don't have anybody to ask. So I had tinkered and YouTubed and trial and error, got some cool stuff working, and I was real serious about taking it to the next level. So I purchased a Udemy course, and that happened to be your course. And it was awesome. And so then I reached out. I wanted to know more. I wanted to know what you knew. I wish you could give me everything you could possibly give me. And yeah, here we are a year later, still bouncing ideas back and forth, projects, and kind of have a friendship.
Cool. No, I agree, and it's great that this online world and this world of Udemy and YouTube connects people with some of these same interests.
Yes.
So why the Pico? Because actually, the Raspberry Pi Pico is not that big a chip, I don't think, in the market, and I don't see huge numbers of adoption for the
Right.
RP2040 compared with ESP32s, 80 Tinies, and
Yeah.
all of those sorts of microprocessors. So, what attracted you to the Pico?
The board that we were already developing on was an ARM Cortex M4 board. And so just when the Pico came out, I had been a huge Raspberry Pi fan since 2009, probably when they started. I had the first board and I've always played with projects with it. So when they came out with the microcontroller, I wanted to see what it was all about. Excellent documentation. It's not so scary for somebody like me to try to fill that world without spending a lot of time, effort, resources. You can really see if this is something that we actually can do before we spend more money, maybe getting maybe an STM based microcontroller. Or and SitePro has they have a computer at every site that they have that controls, it does all the heavy lifting. And so this is more of a supplementary type of thing to do things that they would have a hard time in implementing in software quickly. So we could,
Okay.
I've had 485 Modbus masters over the 485 interface. So that's kind of what led me to lay out the Pico onto a board to get the UART to go to 485 interface, so we could collect Modbus sensor data. And it was just a great board to test my hardware against.
So for people who don't know 485 and that is, give us just the quick explanation of what's 485.
Yeah, so I think everybody's pretty familiar with the 232 standard DB9 ports on a computer, and typically they're made to connect to a printer or one device. When industrial control systems started coming along, maybe in the 70s, Modbus is actually the protocol, but the electrical interface 485 was made. It's a differential pair, and so it's a twisted pair. It's got a 120 ohm characteristic impedance. It's made for robust communication over relatively long distances, not rapid distance, but around a pretty big site, a lot of wires going places around, heavy current. And so it's really good for those types of environments that have a lot of noise, big, heavy motors, pumps, and you just want to sit there and pull all day long and just collect data. It's been really robust and reliable. And it's a daisy chainable interface. And so you can connect up to 250 devices on a leg.
So, when you're working with Pico, you're presumably, trying to lay out boards to place that Pico on. What sort of software do you use? What's the sort of setup are you running on to actually lay out your designs?
I was using KiCad to lay the Pico out because it's a really great piece of open source software. I think if you don't want to spend significant money to get a real awesome CAD software, maybe like Altium or OrCAD, Cadence Allegro, then that seemed like for relatively simple designs, it seemed like the way to go, especially for this company that I'm at. We don't have a ton of money to go waste. We got to pick and choose what we buy. I'm trying to convince them that there's value in this. So I'm also trying to not say, oh, it's cost $10,000. Like I was trying to nickel and dime it for me, go through the pain of relearning a new, CAD software because I didn't come from KiCad, and it seemed great, really similar. So it wasn't too bad to pick that up. Took a stab at laying out a relay board with the Pico. It has a BJT that controls a coil of a relay. It's got a digital input rated for 24 volts, like you'd see in industrial applications, and then it takes the UART interface and breaks it out into a 485 interface through a translation chip. And so with that, I could basically be a Modbus master. I could control a PLC. I could control a VFD. I could control the speed, the frequency, maybe watch what the tanks are doing, and just have a little PID loop almost with something so simple for $4 that, we still struggle with those types of things in the embedded application that we sell.
When you're laying out those boards, are you laying them out in surface mount or through hole?
Yeah, surface mount. And that was like I told you, my mentor, he really taught me, or he asked me if I knew how to solder. I said, yeah. He's like, oh, we'll see about that. And so he said, we need to get you a microscope. And I said, a microscope for what? I was like, what do we need a microscope for, man? And he's like, well, you need to check the soldering joints. And he's talking about the heel and the toe and all this stuff. And I'm like, okay. And so he had me solder some stuff, and it's tiny, of course. So 603, maybe some 0402, but try to stay away from that tiny. And he stuck it under the microscope, and he's checking it out. And he was like, yeah, it looks like a machine did it, man. And so I think he wanted me to solder all that stuff by hand the first time because it really helped me really understand the design, like very intimately familiar after you solder up 100 pieces that are tinier than a fingernail.
Yeah. You've got a very steady hand, much steadier than me, playing around with those sorts of components. I'm going to have to get some tips from you at some point. Converting to surface mount. It's something that is on my list to try out.
Awesome.
So how about test equipment? Because if you're one of my viewers on this channel and you're new to the Pico, you don't really want to be investing in huge amounts of test equipment and development boards and things. What test equipment from a hardware point of view is actually needed? Do you really need an oscilloscope? Is it just a multimeter and a soldering iron? What do you reckon?
I think for me, if I had to start all over, I would definitely buy a benchtop power supply first. I got 3 output power supply. It's so handy to have, and being able to limit the current when you're trying to fire something up that you just soldered. Hopefully you don't have a short somewhere. And I do have an oscilloscope, but I've used it for sure to trigger 485 stuff, maybe to see if something weird's going on, but I don't necessarily think it's an absolute must. You don't necessarily need it. A struggle for me was getting into debugging, like actually debugging code. Like that to me was not necessarily brand new, but no expert in debugging. Like, how do you where do you start when something's not working right? Like, what do you do? I'm real good with the hardware. I check it all out, use my multimeter to check continuity all over my board, make sure VCC and ground aren't tied together, just do all the basic checks. And then, you find some software online, you find GitHub repos, I find your GitHub repos, and then you look at 3 different ones. They're different, but they do the same thing. It's confusing. You don't know who's who's right. Everybody says their way's the right way. And so as a double E, that's the struggle, is like,
I hear where you're coming from, and in my defense and lots of other developers' defense, we often don't realize how complicated the things we do are. and what we're
Right.
doing. Um, you really realize it when you start to explain it to other people.
Right.
And you know, that is one of the things I've learned as I've started, you know, publishing more and more courses on Udemy is, you know, actually, how do you explain this and make it a fairly linear learning curve
Right.
without too many vertical cliffs to climb? And sometimes that's really difficult in things like FreeRTOS kernel, where you're getting into a near real-time operating system and how that manages. Um, some of the stuff in internet protocols and how the internet works, some of that is suddenly you think, well, I'd like to explain this simple thing and be able to do that. But to do that, there are 17 other things you need to understand.
Right.
And uh, that's when some of these learning curves become really vertical, and it is difficult to try and smooth them out. But you know, still have to really, you know, sharing knowledge is important, and I'm passionate about helping people to learn to code, to learn to develop, to learn to design systems. And so, you know, it's working out, well, actually, how do I explain this in bits? The other bit that I think is really interesting is how, you know, our hobby development can start to become sort of commercial and almost a business in its own right. Do you think that the Pico has potential to become, you know, at the basis for small scale sellable projects?
I think so. Um, Here in America, we're obviously we waste a lot of money on a lot of stuff, and we have everything in our house is some type of smart something or other nowadays, whether you want to or not. When I probe around and I look at my network stuff, and you can see a lot of ESP devices, you can see a lot of stuff that's probably not the most secure, and I could definitely see. I don't see why you couldn't use the Pico. It's got a good chunk of RAM, it's got a good chunk of memory, and I'm sure you could add a TPM chip to it and try to make a pretty secure application, embedded application.
No, thank you very much. And thank you very much for joining us today,
Yeah, thank you,
Jordan. It's
John.
been a pleasure talking to you. Hopefully, we can do another one at a later date and talk about some other ones of your projects. That would be
Awesome.
great.
Awesome. Thank you for having me, John.
Let me know what you think about this slightly different format video. Don't worry, my project, product, and technique videos will continue to come. I'm just continuing to explore and innovate about what I can bring to the channel. So your feedback is really interesting. Thank you very much for watching. Please like the video and subscribe, and remember to hit that notification button so you hear about the next video from me. Do take a look at my Patreon page. I'd really appreciate your support in keeping these videos coming. Remember, Patreons get access to my videos up to a week early, and my personal gratitude. Goodbye for now.